So vector product. Vector product or cross product. Vector product or cross product. See, a vector is multiplied by another vector. A vector is multiplied by another vector. So we are getting a third vector. Okay, so the resultant is a vector. So we have seen that is a vector can be multiplied in three ways. A vector can be multiplied by a scalar. So what is the result? That is a vector only. The second case, a vector can be multiplied by another vector. So what is the result? Scalar. Scalar. That is scalar product or dot product of vectors. So in the previous two sections we have discussed, that is dot product of vectors and the numericals of dot product of vectors. So in the first video we have discussed that is the concepts of dot product of vectors. What is dot product? What is the geometrical interpretation of dot product? What are the properties of dot product? Okay, and the important formulae we have discussed. So in the last section we have discussed the 10 numericals related to that is dot product of vectors. Okay. So in this section we are going to see that is the cross product of vectors or vector product. Okay, vector product. See, when a vector is multiplied by another vector, the resultant is the vector only. Okay, vector. So consider two vectors. This is a vector A vector, and this is another vector B. Acha. Okay. So which are inclined at an angle theta. Okay, which are inclined at an angle theta. So what is the cross product of these two vectors? That is A vector cross B vector. It's nothing but the product of the magnitude of the vector. Okay, it is nothing but magnitude of the product of these two vectors and the sine of the angle between these two vectors. Okay, sine of the angle between these two vectors and a unit vector. Okay, and a unit vector. So A vector cross B vector is equal to modulus of A vector modulus of B vector into sine theta into n cap. So that's equal to what is modulus of A vector? That is A. What is modulus of B vector? That is B into sine theta into n cap. So see, AB sine theta gives the magnitude. AB sine theta gives magnitude. You know why? Because A is a scalar, B is a scalar, sine theta is also a scalar. Sine theta is also a scalar. So AB sine theta gives a scalar only. So magnitude. And n cap is a unit vector, which is a unit vector which points or which gives the direction of the resultant vector. Okay, which gives the direction of the resultant vector. So this is a scalar. Okay, AB sine theta is a scalar only. Okay, scalar. This n cap is a unit vector. What is n cap? N cap is a unit vector. N cap is a unit vector. Which gives the direction of the cross product. Okay, that is A vector cross B vector. So the next question is, what is the direction of this unit vector? Okay, what is the direction of this n cap? This is perpendicular to the plane containing A vector and B vector. This is perpendicular to the plane containing A vector and B vector. So suppose consider this is a plane. Okay. This is a plane. So this plane containing, that is A vector, this is A vector, and this is B vector. This is B vector. Okay. So the direction of the normal is perpendicular to the plane. Okay, perpendicular to the plane. So n cap is like this. Okay, n cap. The direction of the normal. So the direction of n cap unit vector is perpendicular to the plane containing, that is A vector and B vector. That is perpendicular to the plane containing means it can be that is like this, or it could be like this. Okay, it could be like this. n. ठीक है. So our next question is, that is, it may be that is perpendicular to upward direction or downward direction. So that is how we can understand. So this is a plane. Okay, understand, that is, imagine this is a plane. So the plane containing two vectors. Okay, two vectors. So our resultant is, that is, the unit vector is either like this or like this. Okay. So our next question is, how we can find whether that is the unit vector is perpendicular upwards or downwards to the plane. Okay, plane. So the direction of this unit vector is can be found using two rules. That is right hand. First one is right hand thumb rule. Right hand thumb rule. And two, right-handed screw rule. Right-handed screw. Using these two rules, we can find, that is, the exact direction of the resultant vector. First one, that is right-handed thumb rule. Okay, right-hand thumb rule. So how we can find? That is, consider these two vectors. Okay, these two are the vectors. Can you see that? Yes. So you just can imagine this is a plane. Okay, this is our plane. So in this plane, these two vectors are lying. So A vector, this is A vector, and this is B vector. Okay, B vector. So this is inclined at an angle theta. Okay, theta. Clear? So right hand thumb rule, what right hand thumb rule says means, so curl your fingers from A vector to, suppose if you want to find, that is A vector cross B vector means, curl your fingers from A vector to B vector. So this is our A vector and this is our B vector. So curl your fingers from A vector to B vector. A vector, this is A vector. A vector to B vector. A vector to B vector. So what is the direction of your thumb? So it is upwards. That is, the direction of the thumb gives the direction of the resultant vector. Okay, understand or not? So this is a plane. Two vectors are lying in this plane. That is A vector and this is B vector. So we have to find, that is, the cross product of these two vectors. So they are inclined at an angle theta. Okay, in between these two vectors we have an angle theta. So what is the direction of the unit vector we have to find? So according to right hand thumb rule, okay, right hand thumb rule, what it says, that is, curl your fingers from first vector to second vector. That is, suppose we are finding, that is A vector cross B vector means this is a vector and this is the B vector. So from A vector to B vector, curl your fingers from A vector to B vector. Now what is the direction of your thumb? That is, the direction of thumb is upwards. Okay, in this direction the normal, that is unit vector, okay, will lie. Suppose if you want to find, that is B vector cross A vector, this is A vector and this is B vector. So first we have found that is A vector cross B vector. Now we have to find B vector cross A vector, B vector cross A vector. So curl your fingers from B vector to A vector, B vector to A vector. In this direction we have to rotate your fingers. Now what is the direction of your thumb? Thumb is acting downwards, okay, downwards. This is the direction of the resultant vector. That is right hand thumb rule says. Okay, so just two vectors in a plane. You imagine two vectors. So these are the two vectors. This is A vector. Consider this vector as A vector and this vector as B vector. So these vectors are inclined at an angle theta. Inclined at an angle theta. So we have to find what is the resultant of the, what is the direction of the unit vector. Okay, unit vector. So curl your fingers. A vector cross B vector means curl your fingers from A vector to B vector. A vector to B vector. So what is the direction of your thumb? Thumb is acting upwards. That is the direction of the unit vector. Suppose if you are finding that is B vector cross A vector. This is B vector and this is A vector. So curl your fingers from B to A. B to A. Okay. So what is the direction of your thumb? Thumb is acting in the downward direction. Okay, downward direction. This gives the direction of the unit vector. That is right hand thumb rule. So another, that is right-handed screw rule. Right-handed screw rule. How we can find? Okay, so A vectors. Again consider this is a plane and these two vectors are lying in this plane, that is A vector and B vector. Okay, so the joining point of these two vectors, place a screw. Okay, place a screw like this. So imagine or consider this is a screw. Okay, suppose if you are finding A vector to B vector, the A vector cross B vector means from A vector to B vector you rotate the screw. Okay, A vector to B vector. Suppose if you are rotating the screw means what? The screw will come upwards normally. So if you are rotating the screw like this the screw go inside. So if you are rotating the screw like this, the screw will come upward. Okay, come upward. So place the screw like this. That is the joining point of these two vectors. Okay, joining point of these two vectors, you place the screw like this. Okay, so this is A vector and this is B vector. So they are inclined at an angle theta. Okay, theta. So A vector cross B vector, from A vector to B vector you rotate the screw. That is, the screw will come upward. That is the direction of the unit vector. It is come upward means the normal, that is the unit vector is acting upward direction. B vector, A vector, B vector cross A vector. From B vector to A vector you rotate the screw. Okay, so if you are rotating the screw in this direction means the screw will go downwards or the screw will pierce. Okay, pierce. So screw will go downwards. So that is the resultant, that is the direction of the unit vector is acting in the downward direction. Clear? So that is the right-handed screw rule. Right-handed screw rule. Okay, so the direction of the unit vector. So A vector cross B vector is equal to modulus of A vector modulus of B vector sin theta into n cap. Okay, so that's equal to, what is modulus of A vector? A, B sin theta into n cap. So this much gives the magnitude. AB sin theta gives the magnitude and the n cap gives the direction of the vector, direction of the resultant vector. So how we can find? That is, the direction of the unit vector is either perpendicular to the plane containing the first rule, that is the first principle, that is the unit vector is perpendicular to the plane containing two vectors. That is the first point. Perpendicular to the plane containing two vectors means it may be acting upwards or downwards. Okay, downwards. So how we can find whether the unit vector is upwards or downwards? Using these two rules, right hand thumb rule and right handed screw rule. Using right-handed screw rule, we can find whether it is acting upwards or downwards. Clear? So what is the geometrical significance of that is cross product? So consider two vectors A and B, which are taken as the two adjacent sides of a parallelogram. Okay, consider two vectors, that is A vector and B vector. Okay, which act as the two adjacent sides of a parallelogram. Okay, parallelogram. So this is O vector origin, OP. Okay, OP vector. So this is A vector. A vector. This is OQ. OQ. Okay, OQ vector. That is B vector. B vector. Okay. So complete the parallelogram. So A vector and B vector, two vectors which act as the two adjacent sides of a parallelogram. So this angle is theta. Okay, theta. OP, OQ, this is OR, this is. So draw a perpendicular. Draw a perpendicular QN. Okay, QN. So this is right angle. Okay, 90 degree. So what is A vector cross B vector? A vector cross B vector. So that's equal to modulus of A vector modulus of B vector sin theta into n cap. So what is modulus of A vector cross B vector? We are taking the magnitude there, because A vector cross B vector is a vector only. Okay, so we are taking the magnitude. Okay, so that's equal to A modulus of A vector A modulus of B vector B sin theta into. So when we take the modulus, that is the vector will change. Okay, vector sign will change. So n cap won't cut. So that is AB sin theta. Am I right? So that's equal to, what is A? That is magnitude, that is OP from the parallelogram. A means that is OP into, what is OB? That is B, that is OQ. OQ sin theta. Okay, sin theta. So from this parallelogram, consider the right angle triangle, that is OQN, from triangle OQN. अच्छा, OQN, ठीक है, OQN. So sin theta is equal to opposite side, that is QN, divided by hypotenuse, that is OQ. Okay, so QN is equal to OQ sin theta. QN is equal to OQ sin theta. Kadam. So that's equal to OP into, what is OQ sin theta? OQ sin theta means we can write that is QN. QN. So that's equal to, what is OP? That is base. Base into, what is QN? That is height. Okay. Base into height. In a parallelogram, that is base into height. What is base into height of a parallelogram? That is nothing but the area of the parallelogram. Okay, area of the parallelogram. So that's equal to area of the parallelogram. Area of the parallelogram. So modulus of A vector cross B vector. Okay, modulus of magnitude of A vector cross B vector is equal to nothing but area of the parallelogram formed by the vectors A and B as its adjacent sides. So the magnitude of the cross product A vector cross B vector is nothing but that is area of the parallelogram. Okay, area of the parallelogram which is formed by the two vectors A vector and B vector as its adjacent side. Okay, adjacent side. So again, that is modulus of A vector cross B vector is equal to, so we can write that is OP into Qn. Okay, so I am writing that is 2 into 1 by 2. Okay, 2 into 1 by 2. That is OP into Qn. So that's equal to 2 into what is half into OP, that is base into height. What is half into base into height? That is area of the triangle of base OP into height, that is Qn. Okay, Qn. So that's equal to 2 into twice of the area of the triangle. Area of the triangle, what? That is POQ. Okay, POQ. 2 into area of the triangle POQ formed by the vectors. Okay, formed by the vectors A vector and B vector. Okay, formed by the vectors A vector and B vector as its two sides. Okay, as its two side of the triangle. Okay, as its two side of the triangle. Two side of the triangle. So here, that is what are the geometrical significance of cross product? Cross product has two meaning. That is the magnitude of A vector cross B vector is nothing but that is the area of the parallelogram which is formed by the two vectors A vector and B vector as its adjacent side. Second one, so the modulus of A vector cross B vector is equal to twice of the area of the triangle, that is POQ. Okay, POQ. So this is a triangle POQ. Okay, POQ formed by the vectors A vector and B vector as its two adjacent sides. That is another meaning of that is A vector cross B vector. A vector cross B vector. ठीक है? Understand? So what is the role of cross product in physics, role of cross product. Role of cross product in physics. So we have a quantity in physics, that is a torque, that is tau vector, is equal to the cross product of r vector cross f vector. Okay. So the position, that is the cross product of or vector product of the position vector and force vector, gives the torque. So when we take the cross product between these two quantities, we are getting another quantity, that is a vector quantity, that is torque. So here we are using, that is vector product. What is angular momentum? Another quantity, that is angular momentum. L vector is equal to, okay, r vector cross p vector, that is linear momentum. That is the cross product. Angular momentum is the product of, that is position vector and linear momentum. So we are taking, that is r vector position vector, that is a vector quantity, position vector. So linear momentum, vector quantity. So we are taking the cross product. So we are getting a third quantity, that is vector quantity, that is linear momentum. So one more quantity is there. We can say, yes, instantaneous velocity v vector is equal to the cross product of angular velocity into position vector. Okay, instantaneous velocity v is equal to r omega. So we say v vector is equal to the cross product of angular velocity into position vector. So this is a vector quantity, it is a vector quantity, we are taking the cross product. So we are getting a third vector quantity. So to handle, that is to manage these quantities, we are using, that is vector product. Okay, vector product. Achha. Then properties of vector product. Properties. Properties of vector product. First point, vector product is anti-commutative. Vector product is anti-commutative. Anti-commutative. So what is the meaning is? So a vector, suppose two vector, that is a vector and b vector. Okay, a vector and b vector. So a vector cross b vector is equal to modulus of a vector modulus of b vector into sin theta into n cap. What is b vector cross a vector? B vector cross a vector, that is equal to modulus of b vector and modulus of a vector sin theta into n cap. Okay, so we can write, that is a vector modulus of a vector modulus of b vector sin theta into n cap. So you just imagine, that is compare, that is a vector cross b vector is equal to modulus of a vector modulus of b vector sin theta into n cap. So b vector cross a vector is equal to modulus of a vector modulus of b vector into sin theta into n cap. So from these two results, shall we write, that is a vector cross b vector is equal to b vector cross a vector. Shall we write? No, because it is not a scalar quantity. Okay, scalar quantity. It is a vector quantity. Okay, vector quantity. So the magnitude is same, that is a vector cross b vector and b vector cross a vector. The magnitude is same, but the direction is different. Okay, direction is different. So we have already seen that. So these two vectors, Okay, so already seen, that is A vector. Okay, so A vector cross B vector. So what is the direction? A vector cross B vector means from A vector to B vector. So the direction is in this. So B vector cross A vector. So the direction is in the direction. So regarding the vector quantity, one quantity that is equal to another vector quantity means both magnitude and its direction should be the same. Then only we can say that one vector quantity is equal to another vector quantity. Okay. So vector quantity means both magnitude and direction should be the same. Then only we can say that one vector quantity is equal to another vector quantity. Otherwise we can't say. So here A vector cross B vector not equal to, that is B vector cross A vector, because magnitude is same, direction is same. So we can say that is A vector cross B vector is equal to minus of, that is B vector cross A vector. It is anti-commutative, because from this what we can understand, that is the A vector cross B vector is a vector quantity, B vector cross A vector is also a vector quantity. They are equal by magnitude, but direction is not equal. So there we are putting that is minus. That minus indicates that the direction is not equal. That is one vector is equal to negative of another vector means magnitude is same, but they are acting in the opposite direction. They are acting in the opposite direction. Okay? Yes. So the second point. Second point. That is vector product is distributive over addition. Vector product is distributive over addition. Distributive over addition. Okay. So what is it? That is A vector distributive over addition. A vector cross B vector plus C vector is equal to A vector cross B vector plus A vector cross C vector. Okay, C vector. So this is the property, that is vector product is distributive over addition. A vector cross B vector plus C vector is equal to A vector cross B vector then plus A vector cross C vector. Okay, distributive. Then third property. Suppose two vectors are parallel or anti-parallel. Suppose two vectors are parallel or anti-parallel. So parallel or anti-parallel. Anti-parallel. Okay, so two vectors. This is A vector and this is B vector. A vector, this is B vector. So they are parallel. Otherwise we can draw like this. That is A, okay, A, and this is B. So the angle between these two vectors is 0. That is theta is equal to 0. Theta is equal to 0. So what is about that is A vector cross B vector is equal to modulus of A vector modulus of B vector sin theta, okay, sin theta into n cap. So that's equal to A B sin 0 into n cap. So that's equal to, what is sin 0? It is 0. So that's equal to null vector. Okay, it's equal to null vector. So that is suppose two vectors are anti-parallel. Okay, suppose two vectors are anti-parallel. Anti-parallel means It is like this. One vector is acting in this direction and another vector is acting in this direction. Okay. So here we can, so this is the origin. Okay, A vector, and another vector is acting in this direction, that is B vector. Okay, B vector. So what is the angle between these two vectors? That is 180 degree. Okay, 180 degree. So what about that is A vector cross B vector? That is A vector cross B vector is equal to AB sine 180 degree. Okay, sine 180 degree into n cap. So sine 180 degree is also, that is 0. Okay, sine 180 degree 0, that is AB. So 0, everything becomes 0, that is equal to null vector. That is also a null vector. Okay, null vector. Okay. So the next property, suppose two vectors are perpendicular to each other. Okay, two vectors, A vector and B vector are perpendicular. That is A vector is perpendicular to B vector. Okay, vector is perpendicular to B vector. This is A vector and this is B vector. Okay. So the angle between these two is 90 degree. Okay, 90 degree. So what about the cross product? That is A vector cross B vector is equal to modulus of A vector modulus of B vector into sin theta into n cap. So AB sin 90. Okay, AB sin 90 into n cap. So what is sin 90? That is 1. So that's equal to AB n cap. Okay, AB n cap. So the modulus of A vector cross B vector, that is modulus, that's equal to AB. Okay, AB. So that is just modulus of A vector cross B vector. Two vectors are perpendicular means it is just that is the product of their magnitudes only. Okay, product of their magnitudes only. So clear? Consider a rectangular coordinate system. Okay, rectangular coordinate system. So this is x-axis, y-axis and z-axis. This is the origin. Okay. So I cap is the unit vector. I cap is the unit vector along the x-axis. J cap is the unit vector along the y-axis, and k cap is the unit vector along the z-axis. Okay. So what is the cross product of, so we have to, that is what is the cross product of I cap cross I cap, J cap cross J cap, K cap cross K cap. So we have to find. So I cap cross I cap is equal to modulus of I cap modulus of, again, that is I cap sine. So what is that is two vectors are I vector. Okay, one vector is I, another vector is also in this direction. So sine 0. Okay, sine 0 into n cap. Okay, n cap. So that's equal to modulus of I1 into modulus of I1 into sine 0, that is 0, into, that is n cap. So that's equal to 0. Okay, 0. So the cross product of any two orthogonal vectors, okay, orthogonal base vectors, that is unit vectors, equal to 0. The cross product of any two orthogonal unit vectors equal to 0. Okay, so I cap cross I cap is equal to 0. J cap dot J cap is J cap cross J cap is equal to 0. K cap dot cross cap is equal to 0. Okay. So what about I cap cross J cap? J cap cross K cap. K cap cross I cap. Okay, so we have to find the cross product of two dissimilar base vectors. Okay, two dissimilar base vectors. For example, I cap cross J cap is equal to modulus of I cap modulus of J cap into sin. So what is the angle between I vector and J vector? I vector and J vector, that is 90 degree. So sin 90 into n cap. So that's equal to 1 into modulus of J 1 into sin 90 1 into, that is n cap. So it's nothing but, that is I cross J is nothing but the unit vector. Okay, unit vector. Okay, I cross J vector is equal to unit vectors, that is 1 into n cap, that is we are getting that is equal to n cap only. So what is the unit vector? I vector cross J vector, that is the direction of the unit vector we have to find. So that is using, that is right hand thumb rule. Okay, right hand thumb rule. I vector cross J vector, I vector cross J vector. From I vector to J vector we have to rotate our fingers. Okay, curl your fingers. Okay, so this is what? This is Z axis, X axis, Y axis, and this is Z axis. Okay, so our thumb is along the Z axis. Okay, thumb is along the Z axis. So what is the unit vector? So that is Z axis we have drawn like this. Okay, this is the Z axis. So what is the unit vector along the Z axis? K vector. So n cap means we can write that is K cap. Okay, I vector cross J vector is equal to, we can write that is K cap. Okay, K cap. Right. So what is J vector cross K vector? J vector, J cap cross K cap is equal to J cap cross K cap is equal to modulus of J cap modulus of K cap into, okay, sin. So what is the angle between, that is J and K? So that is 90 degree only. Okay, 90 degree. Sin 90 into n cap. So that's 1 into sin 90, that is 1 into n cap. So from K2, okay, K2 J vector cross K vector. Okay, J vector cross K vector. So K vector is like this. Okay, so we have drawn like this, but what is the direction? That is Z axis is like this. Okay, like this. From J vector, from J to K, so rotate the finger like this. So this is J vector. K vector is along like this. So from J to K, rotate your finger. Okay, rotate your finger. So what is the direction of the thumb? Thumb is along the x axis. Thumb is along the x axis. So that's equal to J vector cross K vector is equal to I cap. Right? I cap is equal to I cap. Right? So next we have to find that K vector cross I vector. k vector cross I cap is equal to, so modulus of k cap modulus of I cap sine, so mutually perpendicular, okay, 3 axis, that is sine 90 into n cap. So modulus of k cap 1, modulus of I cap 1 into sine 90 1 into, that is n cap. So that's equal to n cap. That is the unit vector. So what is the unit vector? So k vector is like this, okay, k vector into I vector. So how we can find k vector is acting in this direction, so k vector to I vector, so you have to rotate, that is k vector to I vector. So from this vector to this vector you have to rotate. So what is the direction of the thumb? Thumb is along the y axis. So that is, what is the unit vector along the y axis? That is j cap. So we are getting, that is k vector cross I vector is equal to j cap. Okay. Okay, k vector cross I vector is equal to j cap. So what about, that is I vector cross j vector is equal to k cap. What about j vector cross I vector? J cap cross I cap. So we have studied, that is a vector cross b vector is equal to, we have already studied, that is anti-commutative, okay. So a vector cross b vector, a vector cross b vector, right? Anti-commutative, what we have studied, that is a vector cross b vector is equal to minus of b vector cross a vector. We have studied anti-commutative. So by that principle, so we can write, that is I vector cross I vector, I cap cross j cap is equal to k cap. Okay, j cap cross I cap is equal to, that is minus k cap, right? So similarly, that is k cap cross j cap is equal to minus I cap. I cap cross k cap is equal to minus j cap, right? Correct. Similarly, that is I cap, for easy understanding, that is I cap j cap, I cap j cap and k cap, cap. So I cap cross j cap, so okay, I cap cross j cap, we will get k cap, okay, k cap. J cap cross k cap, okay, j cap cross k cap, so we will get I cap. So k cap cross I cap, okay, k cap cross I cap, we will get j cap. So that is in the clockwise direction, okay, clockwise direction. It's not as clockwise direction, okay. So I cap cross, so I'll positively, okay, this positively, positive, okay, positive, this is also positive, this is also positive, okay, positive. So I cap cross j cap, so we will get the next one, that is positive plus I plus k cap. Then j cap cross k cap, so we will get I cap. I cap cross j cap, so we will get k cap. So it is in the clockwise direction, okay, clockwise direction, that is positively, okay, positively. J cap cross I cap, okay, so like this, j cap cross k cap, j cap cross I cap, so we will get minus k cap. So here, so j cap cross I cap, so minus k cap, so here You have to put minus. It is in the anti-clockwise direction. Okay, anti-clockwise direction. So I cap cross k cap. J cap cross I cap. Then I cap cross k cap. Okay, I cap cross k cap. I cap cross k cap. So cross. So we will get what? Minus I cap. Okay, minus I cap. K cap cross j cap. So I cap cross, that is minus j cap. Okay, minus j cap. So this is also minus. Okay, so anti-clockwise direction. So the next one, k cap cross j cap. So like this. Okay, k cap. So that is cross. This is also minus. Okay, minus. So this one, that is clockwise direction. So all the values are positive. So that is cross product of 2. So we will get the third one. Okay, third one. So positive direction. So positive, all the values are positive in the clockwise direction. So that's one in the anti-clockwise direction. All are negative values. Okay, negative values. So this is the somewhat easy method to remember. Okay, remember. Clear? Suppose the vector is represented in rectangular component form. Okay, component forms. For example, a vector is equal to ax I cap plus ay j cap plus az k cap, and b vector is equal to bx I cap plus by j cap plus bz k cap. Okay, so the two vectors are represented in rectangular component form. So what about it? That is a vector cross b vector is equal to determinant. Okay, determinant I cap j cap k cap. Okay, k cap. ax that is ay az, then bx by bz. Okay, bz. So how we can expand? That is equal to I cap into. Okay, so this row, this row and this column cut. Okay, so next ay bz minus by az. Okay, so the next is minus j cap. So cut this row and this column. Okay, this column. Okay, this column. Okay, this column is cut. So what will come? That is ax bz, like this. ax bz minus bx az plus k cap into. Okay, k cap. So cut this row and this column. Okay, this column. ax by okay, ax by minus bx. So this you are studying in mathematics. Okay, so how to expand the determinant. Okay, determinant. So anyway, that is if the two vectors are in rectangular component form. Okay, component form means a vector cross b vector is equal to, so we have, that is we have to use the determinant method. Okay, so how to expand the determinants you are studying in mathematics. Okay, mathematics. So in this way we can solve it. Okay. So the next is A vector cross B vector. Okay, A vector cross B vector is equal to modulus of A vector modulus of B vector sin theta into n cap. Okay, sin theta into n cap. So what is modulus of A vector cross B vector is equal to A vector cross B vector is equal to modulus of A vector modulus of B vector into sin theta. So when we take the modulus, that is the vector will change. Okay, vector will change. So from this, sin theta is equal to modulus of A vector cross B vector divided by modulus of A vector into modulus of B vector. Very, very important formula. That is the sine of the angle between sine of the angle theta between the two vectors. So this formula we can use to find the angle between the sine of the angle between two vectors. Okay, sin theta is equal to modulus of A vector cross B vector, then divided by modulus of A vector into modulus of B vector. Okay, then so what is the formula to find the normal? Okay, normal between, that is, A vector and B vector. So this is a plane. This is a plane. So this plane contains two vectors. Am I right? So this is one of the vector, that is A. This is another vector, that is B. This is the origin, that is A vector and B vector. Okay, B vector. So this normal is, I think, okay, that is unit vector. Okay, unit vector n cap. So what is the formula to find the unit vector? Okay, unit vector. What is the formula? That is, we know A vector cross B vector is equal to modulus of A vector modulus of B vector sin theta into n cap. Okay, so take it as equation number 1. So modulus of A vector cross B vector is equal to modulus of A vector modulus of B vector, okay, into sin theta. Okay, sin theta. So now one implies that is A vector cross B vector is equal to, so with this, instead of this, that is modulus of A vector into modulus of B vector into sin theta, modulus of A vector into modulus of B vector into sin theta, what we can write, that is modulus of A vector cross B vector into n cap. So from this, n cap is equal to A vector cross B vector divided by modulus of A vector cross B vector. Okay, so this is the formula we are using to find the unit vector, Okay, so n cap is equal to A vector cross B vector divided by modulus of A vector cross B vector. Okay, so very important formula. So with this, this session is over. That is the concepts of cross product of vectors. So in the next section, we will meet with 10 numericals of cross product. Thank you.